Right, so solving a quadratic, finding its roots, solving f of x equals 0, we've got a few options. So just want to check that you're all happy with it. So if I said to you solve x squared plus 5x plus 5 equals 0, what would you do? The first step is to try doing... Actually not, no. I mean, we could, but what are we trying to find when we find it equal to 0? Jesse?
The x and y coordinates.
Of?
Parabola.
I'm trying to find these two things, aren't I? The roots, finding its roots. Alright, what was completed square form for? Finding the... This is important. Don't just get into a habit of doing these, so those of you that are still not listening to me, don't get into a habit of doing the question without remembering what it's for.
Well, wasn't it for vertex?
So completed square form was vertex form, yeah? Remember that? Okay. I am trying to find its roots. So what's the first useful way of finding roots? What do we put it in? Which form? If it's not standard form, factorized form, thank you. Yeah? So I try and do factorized form first, and it's going to be x and x. Actually, I might have given you one that's, I'm going to change this to 6. That'd be better. Might make it easier for you now. Plus 5 and plus 1. Okay. Alright, so what are the solutions? What are the roots? X equals -1 and x equals -5. So what are the coordinates of the 2 points? So actually my axis here shouldn't be there. It should actually be over here somewhere. Alright, so the coordinates would be -1, 0, good, and -5, 0 if I ask for the coordinates. So they're the roots. Alright, if I asked for the vertex, we have another way to do it. Okay, we can find halfway between those values, yeah? Remember doing that? However, what I want to do is I want to show you how you use vertex form, how you use completed square form to also do the solutions. So let's have a look again at x squared plus 6x plus 5 equals 0. Can you tell me how to do that in completed square form now? So it's going to be bracket squared, it's going to be x plus 3 squared. If I expand x plus 3, that's going to be x squared plus 6x plus 9. But I need plus 5, so I need to subtract 4. So it's going to be... Okay? So this is the interesting... First of all, what is the vertex now of that curve? Yeah?
-2, -4.
It would be -3, -4, yeah? Remember we said that? It's the opposite of what's in the bracket, but it is that one. So this is the y, this is the, I would say it's negative x, because we take the opposite side. Alright? The question is, so I can tell my vertex is -3, -4, but what if I were to ask for the solutions, the roots? I know what they are, they're -5 and -1. But is there any way of using completed square form to find those roots? So I've got x plus 3 squared minus 4 equals 0. What's the process of finding the roots, but from this form, not factorized form? you're all, well, not all of you, some of you did what I suggested and went back into the booklet. A lot of people have just ploughed on with that front page. Have you actually been doing the solutions, or have you just completed square form? A lot of you have just put it in complete square form, not actually done the solutions. So this is the completed square form, but equals 0. Now what do I do? I want the roots. Again, we know what they are, but I want to know what these two are, but confirm them using this form. How do I do it?
I know always you could work backwards and then expand it and work from there.
Well, yes, we could expand it, then factorize it, and then do it that way. We don't want to have to do that. Well, what we do is we can rearrange and solve quadratic in this form now. We've only got one x, so I'm going to add 4 to both sides, and I get x plus 3 squared equals 4. Then you square root each side to get rid of the square. That leaves me with x plus 3 equals what? And what is the square root of 4? 2. But also negative 2, no? What's the square root of 4? 2 and negative 2. Yeah? When you do a square root, you must always do positive and negative. So now I've got my two options for x. So x plus 3 equals 2. Subtract the 3. Gives me x equals negative 1, which we agree on. This was, subtract the 3, gives me x equals negative 5. Again, we agree on that. All right? Same two numbers as before. So that's how we can use completed square form as well to find the roots. We don't have to go back to factorised form. All right? So, just to follow up on that then, if you had another example and I asked you to solve x minus 2 squared plus 7 equals 0. Okay.
The same we just did.
Okay, what would we do? Someone else. I've got same two hands going up all the time. Paris.
Minus 7 on each side.
Minus 7 on each side gives me x minus 2 squared equals negative 7. Next stage.
Square root.
Square root. So if I square root both sides, I get x minus 2, square root gets rid of the square, equals the square root of negative 7. Do I do positive or negative?
Yes.
Yeah? Okay. What do I do to finish off then? Yeah.
You do x minus 2 equals negative, and then...
Well, I have to finish off the rearrangement, so I actually do add 2. Yeah. So that becomes x equals 2 plus negative 7 and 2 minus negative 7. Okay. Is everyone happy with both of those roots?
Yes.
Yeah? No problems with that at all? No? Happy with the process? Happy with the solution? Yeah? I would much rather someone was unhappy with those solutions for a reason.
Are they not finished? Don't you need to put it into your calculator? And
You could.
you need
I'm actually, this is fine. This form is fine. It's exact form. I just have a problem. There it is. Yeah, there you go. Is that what you were going to say? Can't have a negative square root all the way up here, look. That is a big problem. It's a big problem. But Where did I go wrong? Or did I not go wrong? If I didn't go wrong, what does it mean?
It's a faulty equation.
Say again?
Can't do the equation.
You can't solve it, yeah. This means there are no solutions. So I should not have gone past that point. So all of this, just don't do it. But what does that mean in terms of the graph itself, the function? This tests your understanding of the roots thing. Any ideas? Go on.
It won't touch the x-axis?
Well done. It'd be something like that. It does not cross the x-axis. So that is what no solutions means. It doesn't cross. There are no roots. And you must be okay with that. Do you remember doing the formula, the quadratic formula for solving these?
Yeah.
Do you remember talking about the discriminant?
Yeah.
Yeah.
The b squared minus 4ac? And if that was a negative, no solutions. If it was a positive, 2 solutions. If it was 0, 1 solution. So that's an example of no solutions. An example of 1 solution is where it touches the axis just once, it doesn't cross. And 2 solutions you're already used to seeing. So that's 2 solutions, that's 1 solution, that's 0 solutions. Okay? And when you solve, even when you solve it using vertex form, you have to be okay with seeing those things. So you've got 2 things there in those notes we've just taken. The first step is, are you happy with going through the process? So I could make this question solvable by doing what? What change could I make to this question to make it solvable?
Instead of doing add 7, you do subtract 7?
Yeah, you obviously got this down. Yeah, if I change this to from plus 7 to subtract 7, when I then add 7 on the other side, this would be a positive 7. Then I'd be able to do it. Does that make sense? Okay. All right. I think